Hi, this is Maggie from Design Code Debug Repeat. If you're a beginning programmer, a beginning game programmer, a programming teacher, or if you just find this content interesting, please subscribe to the channel. I'll be posting lessons, tips, and cool programming stuff regularly. And I think today's topic is really cool. We're going to use a facial recognition library to finish off our accordion illusion program. So I really wanted to have some facial recognition software to find the eyes, the nose, the mouth, the top and the bottom of the head, all of that, rather than make the user click on the head so that we can scale the skull to fit the face. And if you're not familiar with the program I'm talking about, I'll just include a link in the description and right here to the first video in the series where we created some software for this illusion. So facial recognition, it's pretty common, so I knew that I would be able to easily find a library to do this for me. So I found this article on towardsdatascience.com, and it's about the face recognition library. So this is the library that I decided to use because it looks really easy to use. And it was not super easy for me to install. I tried to install it, and then I found out that I needed a 64-bit version of Python, so I installed a new Python. I guess I forgot to check the box, so I had to go back and change my paths variables. And then once I got all that working, then there were a number of packages that I needed to install, including Visual Studio C++. But eventually, I got everything installed, and I basically just followed the method of try to install it, look at what error I get, fix that, try again, look at what error I get. It took a little bit of time, but we eventually got there. And I'm going to say it was well worth it because this is just so cool. So before I show you the final versions of the accordion illusion program, and I made a number of changes from the last version, and I wrote a couple of programs to accomplish different tasks, I thought we might just play with the facial recognition or face recognition library just a little bit. So I've got a really simplified version of the program here where we just get an image from the user, and then we'll run a couple of the functions from face recognition. We'll do face landmarks, and we'll do face locations, and we'll just print those out so we can see what we get. So I'm going to run this, and I have a few pictures. So the first one, I'm just going to pick that initial picture of the young gentleman from Wikimedia. Okay, so I printed in order the face landmarks and the face locations. And so for face landmarks, you can see we have a dictionary here, and it says chin, and then it just has a bunch of points. So we could use that to draw a polygon, to draw a polygon with pygame, for example, around the chin or around the eyes or any of these features. So we've got nose tip, right eye, left eye. We've got the eyebrows, we've got the bottom lip. So yeah, that looks like top lip, bottom lip, right eye, left eye, chin, and left eyebrow, and right eyebrow. And then this one was just face locations, which you might use to put a rectangle around a face, as in the image here at the top of this article. Well, actually, let's look at that for a minute. So you can see this isn't perfect, and it's not going to give me the rectangle that I need to put the skull on the face, because what I noticed is these rectangles are basically rectangles around the features that it's identifying. So the eyebrows, the chin, all of that. And sometimes when I ran it, it was skewed a little to the left of the face and skewed a little to the right. I'm not complaining, by the way. I am thrilled that this library exists. I'm just saying it's the tool we have, and to use it, we need to figure out how to use it given what we have for what we want to do. Okay, so with the box, this is top, right, bottom, left. Okay, so why don't we, well, before we play around with that, let's choose a different image, one that has multiple people in it. So again, I went back to Wikimedia and looked for pictures in the public domain, and I found this one. I wanted one with a lot of people. I found this one of an abortion rights rally. And we can see, well, I don't know if it'll pick up this person, but we can see at least 4 people. Well, we can see 6, but I think we should expect that it would pick up 4. Oh, here's another person, you know, here's a hat, so I don't think it would pick up a hat. But it would be interesting to see how many the software picks up. Looks like it only found 3. So I wonder if maybe the little girl, because I haven't put rectangles around this yet or anything, but because her face is to the side, or maybe this person because she's wearing sunglasses. Oh, she's a little to the side too. So it'll be interesting to see which people it picked up, or maybe we can guess by looking at the coordinates. But so notice that what we get from face locations is a list of tuples. So a list of top, right, bottom, left for each of the people in the image. And so the same thing with the face landmarks. We're getting a list of dictionaries. Okay, so let's use our image or any of our images, and instead of printing the face locations, let's split rectangles or draw rectangles onto the face using those face locations. So instead of printing them, so we can say for face in face locations, for example. And so that's going to be a tuple in this list. And we'll do pygame.draw.rect, and we will draw to our surface. We'll just draw directly to our image, which I just have the user give me the name of an image, and then I load it into a pygame surface and make it the screen, as you can see. But then we also have to load it in, so again, using the file name, to the face recognition library into its format, and then it can run its algorithms on it. So I will draw onto the pygame surface that I created, which is image. Okay, image, we'll do green. And then here's where we'll construct a rectangle from that top, right, bottom, left tuple that we've got. And then we want to say width equals like 1 or 2 so that we don't get a solid box over each face. So I always need to refresh my memory on, let's just go to rect. So we can do left top width height. So let me bring this down. So left is face, remember, is one of these tuples, and left is the third at index 3. It's the fourth. So face sub 3 is left. Top is the first one, so face sub 0. And then we want width, so that's going to be left minus right, so face sub 3 minus face sub 1. And then we want the height, and so that's going to be face sub 2 minus face sub 0, right? There we go. Oh my goodness. Okay, so you can see this one, like it feels a little skewed to the left. By the way, I did edit this to try to make him facing forward a little bit more. That was because of my skull picture. So this isn't the exact image. All right, let's run it. We don't need that anymore. Let's run it with the image with multiple people and see which ones we're finding. Okay, so it's the sunglasses that threw it off. Okay, so I found 3 people there. Okay, so that's fun, right? But we can do other things with the landmarks, which is also really fun. So let's say, like, for face in face landmarks, because remember this one, I shouldn't have closed that because then I don't remember the dictionary keys. Let's print face landmarks. Okay, I'm pretty sure we have like left eye and right eye. So let's say pygame.draw.polygon, and it's poly, I think. Okay, let's go look. Pygame draw. What is polygon? Okay, so surface, color, points, width. Okay, so surface, let's do red, color, points, and then we'll do width equals 2 again. But for points, we can just grab one of those dictionaries. So we'll print it again so you can see. But let's do the left eye. So we'll say face, I think it's left. Now see, I don't remember. Okay. It's in my other code. Oh, well. Okay, we'll do a quicker picture of a young gentleman. Okay, it's left underscore I. Okay, so we'll do a left underscore I. And well, let's get that one working, and then we can outline everything. So there's his left eye, but we can just do lots of polygons and just get all those facial features. So we've got the left eye, we've got the right eye, and we've got the left and right eyebrow, right? We've got a nose bridge. Well, let's just do a few things. So we'll do that eyebrow and the right eyebrow, and let's do his nose tip, where whoever is in the picture, we've been using him. Nose tip. Okay. Okay. And let's run it again. I probably should have quit it, but let's run it again and choose the picture with more people, see what we get for them. Okay, so pretty cool. That is pretty cool, right? I think it's cool. There's a lot you can do with it. So you can play with that, of course, but let's take a look now at the programs that I wrote. So that's experimentation, that's one more. Here's the better transparency one. Let's look at that. Okay, so first of all, I edited the image of the skull, and I have a bunch of skull images. So figuring the person might want to pick a particular skull image and see which one works best with the face image. So for example, with this young gentleman, I found that the most transparent skull that I created worked the best with him. But then I took a picture that I had of just a bunch of people where I work, and I did pick their pictures, and they weren't portraits, they were actual photographs, and the less transparent skull really didn't work with them. A more transparent skull worked. So I think it depends. So if we run this, oops, that's the experimentation. So if we run this, it first asks for the image of the person. So just keep working with the young gentleman. And then it asks for you to pick whatever skull you want. So more transparent black teeth is the one I'm going to pick. Okay, now not only does it write out the finished image, but it also writes out the superimposed skull image. So it writes out this one as well, so that you can edit it if you want to. So for example, I decided to soften the edges and copy his hair back over for this one. So then I wrote another program, make accordian from 2, which allows you to upload 2 pictures and just do the sliced image from those 2 pictures. So you could use the first program if you didn't like the superimposed skull image, but you would be able to adjust it yourself. Then you could adjust it and run the other program to get the sliced image. Okay, so that's one change that I don't think is all that interesting. I think using the facial recognition software is probably the most interesting thing. The other change that is not that interesting is I gave the skulls an alpha channel so that we don't need to do this transparency stuff anymore. Now, I left it in because I had made some changes. I'm using smooth scale instead of just scale, and that caused some problems where the whites were no longer white, so I couldn't set a color key. So I used this threshold function to set anything that was close to white back to actual white, so I could set the color key, and then I set the alpha on the whole surface. But we don't need any of that anymore if our image is a ping with an alpha channel, which it is now. Now, when we have the ping with the alpha channel, we have to set this constant, or pass this constant in source alpha when we create surfaces that we're going to blit that image with the alpha channel to, or it won't be recognized. So those are a couple of differences that aren't using the face recognition library, but that I think that you just might want to be aware of in this version of the program. And this is the version I'm going to upload, which is why I'm leaving this code in. Okay, so just like before, I load the image in the facial recognition format. And then I find the landmarks of the face. What I wanted to do was scale the face based on the distance between the eyes, and that would be the horizontal scaling, and scale it vertically based on the distance between the eyebrows and the chin. I tried scaling it initially with that box that it creates around the face, but as I mentioned, it's too short. Or maybe I could use that. I guess I could use that once I changed to using this method, because what I did was I went in and measured my skull in Photoshop, and I had to do that because the facial recognition software does not recognize the skull as a face, so I couldn't take the skull and do this programmatically. So with those landmarks, I draw a polygon around the left eye and the right eye because that returns a rectangle, which is the bounding rectangle for the left eye and the right eye. There's probably a programmatic way to do this. I just saw that drawing the polygon returned the rectangle, so I drew it on a throwaway surface, and I'm using the rectangle. And then I calculate the difference between the centers of the eyes, and that's the portrait eye difference. The difference between the centers of the eyes on the skull is 380 pixels. So I use that to come up with the ratio, what I'm calling the width scale factor, for scaling the width of the image. And then I get the width of the skull image and just multiply it by that width scale factor to scale the skull, or I will be using that to scale the skull. Now for the vertical distance, I did the same thing with the eyebrow, I think the left eyebrow and the chin. So I got the bounding rectangles for those, calculated the difference. This time I did between the bottom and the top, and in Photoshop found that difference roughly on the skull, doesn't have eyebrows or chin really, but that difference on the skull is 870 pixels. So then I came up with a height scale factor and calculated the skull height from that. So then I just blitted the skull to, I blitted the image to, this is the final surface that I'll be returning. So I blitted the image of, let's just say the young gentleman. And then I decided I wanted to bug out the eyes and make them bigger in the final image, because in a real skeleton, is it a real skeleton? No, why am I saying that? In skeletons that we see in movies, with all the flesh gone but the eyes left in, which I'm sure doesn't happen with real decomposition, but I actually have no idea, because, I mean, you would think the eyes would decompose the same as everything else. But if a skeleton had eyes, they would appear large because there's no flesh around them. So I decided to bug out the eyes. So I blitted the eyes to their own surfaces and then increased them by a factor of 1.5, and then adjusted where they would be on the face based on the fact that they're larger, and then blitted them back to our skull image. So I blitted the face to the skull image, and then I enlarged the eyes and blitted them back over the skull image so it would have larger eyes. That, of course, you could take out if you thought that looked weird. I thought the eyes looked like they were sort of disappearing in the original image, and I thought, just based on our culture and what we see of skeletons with eyes, that them looking bigger might make sense to people. Okay, so then I scaled the skull according to width and the height that I calculated from taking the difference between the eyes and the chin and the eyebrow, and used the smooth scale for that. And then I had to figure out where to blit the skull over the face. So again, in Photoshop, I found the distance from that left eye center to the top of the skull and to the left of the skull, or I'm doing that the wrong direction, to the left of the skull, and for this one to the top of the skull, and then used my scale factors to figure out what size that now is on the skull, now that we've scaled it, and then subtracted that distance from the center of the eye to figure out where to blit, and blitted that. So that's, the rest of it is basically the same now. The slicing is the same. Again, we're saving out the two images, so we're saving out the sliced, but before, right after we create the superimposed skull image, we're saving that out. And so you can see the eyes are bugged out here. They're just bigger. They're not blitted over the skull, but they're just larger. And I'm sure this can be improved in many ways, but I really had fun with the face recognition library, and I don't know what else we can do with it with this particular project, but I think that I look forward to using it in future projects. So if you liked this video, please give it a thumbs up. If you have something to say to me about it, please comment. I'd love to have a conversation about it. This is my first time playing with any kind of facial recognition, so you're probably more experienced with it. Maybe you've played with it before. I'd love to know your thoughts, or if you haven't, if you have questions, if there's something that I didn't go into in enough depth, anything at all. Love to chat with you. All right, if you like this sort of content, please subscribe to Design, Code, Debug, Repeat. Take care.